بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. ازيكم أبناء الطلبة؟ النهاردة هنكمل part 2 of our lecture Introduction to Muscle. We will discuss إن شاء الله the third type of our muscle in our body is skeletal muscle. Here is the organization of skeletal muscle. Skeletal muscle is formed of groups of fascicles. These fascicles is formed from muscle fibers, which is called the cell. Cell of the muscle is called muscle fiber. This muscle fiber contain in its sarcoplasm myofibrils, and these myofibrils will contain or contains thick and thin filaments. Thin and thick filaments, as we see in the picture. This is the muscle, tendon of the muscle, and this is the fascicles. The fascicles is formed of muscle fiber, and the muscle fiber is surrounded by sarcolemma, and this muscle fiber is formed of several myofibrils. And myofibrils contain thick and thin filaments, as we see in the picture in front of you on the left side of the slide. What about internal organization of the muscle fiber or composition of the muscle cell? The muscle fiber is multinucleated, as we said before, behaves as a single unit. Each muscle fiber in skeletal muscle contract alone, not in contact with its neighbor muscle fiber. Each, unlike skeletal cardiac muscle and smooth muscle. Smooth muscle, what's called single unit muscle, all muscle fiber contract with each other, and in the heart, all the muscle fiber of the ventricles contract with each other, and both atria contract with each other. But here in skeletal muscle, only the single muscle fiber contract only cell. Okay, it contains bundles of myofibrils, which is surrounded by sarcoplasmic reticulum, invaginated by transverse T-tubule, as we see in the picture in the next slide. Each myofibril contains interdigitating thick myosin and thin actin myofilaments arranged longitudinally in sarcomeres, forming alternating dark A and light I bands respectively. Repeating units of sarcomere account for striated pattern of skeletal muscle. A sarcomere runs from Z to Z line. It is the contractile unit of muscle fiber. Here we will discuss the previous or repeat the same on this, the same speaking أو نفس الكلام اللي اتقال في previous slide. We will repeat it on the picture. As we see here, it is the muscle fiber or muscle cell, muscle fiber or muscle cell, composed of several myofibrils. Okay, one myofibril is composed of thin filaments which is called actin, and thick filaments, which is called myosin. And each myofibril is surrounded by what is called sarcoplasmic reticulum, which is a blue color in this picture, and is invaginated by surrounding T tubule, which take the yellow color in this picture. Sarcoplasmic reticulum is tubule. reticulum means شبكة من الأنابيب أو الtubules, and invaginated by another tubule which is called a T tubule, which is surrounding sarcoplasmic reticulum. So sarcoplasmic reticulum like a كيراتين زي الستارة، والتي تبيول زي البلتكانة بالظبط، بنفسرها أو بنشبهها بكده. يبقى أنا عندي الساركوبلازميك ريتيكولم بيبقى around the myofibril like الكيراتين وinvaginated by the T tubules. هنشوف الfunctions of this sarcoplasmic reticulum and T tubules next. This picture illustrates the arrangement of thick and thin filaments that produces the banding patterns or striated patterns of skeletal muscle. Okay, here the dark purple color is actin fiber, and the pinkish color or dark pinkish color is myosin fibers. We see, and between two Z line is sarcomere, which is repeated longitudinally in the myofibril, gives the striations to skeletal muscle fiber. Okay, as we see down in the picture. Okay, purple color is alternate with a dark pinkish color, and so on. This light band which is formed of actin is called the I band, and the dark band which is formed of myosin interdigitate with actin is called the A band. Repeated I band with the A band, as we see, produce illustrations of skeletal muscle. Here is a small section of myofibril which show the sarcomere, show the composition of sarcomere. Note that thick myosin filaments are arranged between overlapping actin filaments in the center of the A band, or occupy all the A in the center of the sarcomere and occupy all the A band. That is to say, the A band is formed of myosin and interdigitate with actin at the periphery of the A band. Okay, and we see in the I band or light band at the periphery of the sarcomere, which is formed of actin filaments only. Okay, the two Z lines marks the boundary of the sarcomere. Repeating sarcomere longitudinally in the myofibril will produce striation. And a very important point about sarcomere, it is the contractile unit of the skeletal muscle fiber, as we discuss in the next lecture, inshallah. Now we will speak about thick filaments. Okay, it contains myosin only and are present in dark band in the center of the sarcomere, as we see in the previous picture. Each myosin molecule has two heads, as we see down and to the left in the picture. has two heads attached to a single tail. Two heads, as we see, attached to a single tail. The myosin heads bind to adenosine triphosphate and actin, and myosin heads are involved in cross bridge formation, as we discuss next. Each cross bridge is flexible at 2 points called hinges. hinge معناها مفصلة، زي مفصلة الباب بالظبط بتتني وتتفرد بالظبط مفصلة الباب. One hinge present at the arm where one hinge where the present when the arm leaves the body. When the arm leaves the body, here the arm, okay, and the other one or the other hinge when the head attached to the arm. يبقى we have two hinges. One hinge when the arm leaves the body or tail, okay, and the other when the head attached to the arm, okay. Thin filaments are anchored at the Z lines, or what in other words is Z line fix thin filaments, and are present in the light eye bands, okay, interdigitate with myosin filaments in the periphery of the A dark band. Contains number 1 A الأكتين, B tropomyosin, C troponin filaments. يبقى thin filaments 3 types: actin, tropomyosin and troponin. الأكتين is the main components of other thin filaments. يبقى نسبته أكتر الأكتين. الأكتين molecules are globular in shape. They join together to form an actin filaments. زي الكور تتحد مع بعضها وتعمل filament. الأكتين filaments are twisted into a helix. On each actin molecule a myosin binding site where the myosin head can attach. يبقى عندي على كل أكتين مولكيول اللي هو الجلوبولار اون شيب أو زي الكورة في مايوسين بايندينج سايتس، مكان للمايوسين هيد can attach to this actin molecule. Okay, المايوسين lying side by side with actin filaments in a ratio 2:1, that's to say 2 actin per 1 myosin. As we see in the previous picture, we see actin in myosin, and above it is actin, and below it is actin molecules. Okay, here or this picture shows the myosin cross bridge attached to its binding site on the actin filaments. Here above the picture, this is the actin filaments. Okay, and this dark or this black points, okay, or circles is the myosin binding sites, and this is the cross bridge which is formed of the arm of the myosin molecule and the head. Both are called cross bridges، يعني زي ما نقول كوبري وصلة. okay. Here also we see the hinges between the arm and the body of myosin المفصلة. Okay, and there is another hinge, okay, between the head and the arm. Okay, during contraction the cross bridge or the myosin head will contact with this dark or black dark circles in the picture and move the actin on to the center of the sarcomere, as we discuss later inshallah next lecture. Other thin filaments is tropomyosin molecule. They are long filaments located in the groove between two chains of actin molecules. During rest, tropomyosin cover the myosin binding site on actin molecules. Tropomyosin strands are held in place by troponin molecules. What is the function of tropomyosin? Tropomyosin cover المyosin binding sites on actin molecules. Act on contraction or relaxation. Tropomyosin on relaxation because it covers the binding site between الactin and myosin. زي ما قلنا once the cross bridges or المyosin head come in contact with المyosin binding sites on actin will start contraction. Here tropomyosin cover these binding sites. Tropomyosin keep in place by troponin molecules. Troponin molecules are globular in shape. They are located at interval along the tropomyosin molecules. It is made up of three subunits, I, T, and C. Troponin I inhibits the interaction between the actin and myosin. This is very important because once actin become or myosin become with actin, contraction is start. So any protein inhibit the interaction between them considered as relaxing protein or produce relaxation. يبقى قلنا tropomyosin ده يعتبر help relaxation of the muscle. And number 2 troponin. Troponin T bind with tropomyosin. Okay. Troponin C contains binding sites for calcium. Calcium is very, very important in muscle contraction and it starts the muscle contraction. This picture shows us the structural relationship between troponin, tropomyosin, and actin. The tropomyosin is attached to actin, as you see, whereas the troponin complex of three subunits is attached to tropomyosin not directly, but it keep the tropomyosin in place and not movable. Okay. T-tubules and sarcoplasmic reticulum. This is a system of tubules located in the sarcoplasm of muscle fiber, as we said before. The T-tubules run transverse to myofibrils, then open to the opposite side of the muscle fiber, okay, filled with interstitial fluid, okay. They are located at the junction of the A and the I bands of the sarcomere. Very important. Okay? Why important? We will discuss in muscle contraction. Okay? Next lecture. Functions of T-tubules, they transmit the action potential quickly spreading from the sarcolemma to all parts of the muscle fiber. يعني التي تبيول بتعتبر نقول ايه يعني مجرى مائي للتوصيل، يعني مجرى زي قناة بالظبط، مجرى مائي للتوصيل الاكشن بوتنشال. اوكي، منين؟ من على السيرفيس اوف ذا sarcolemma او السيل من المسل فايبر into the interior of the muscle fiber. Okay, at the same time, okay, release the calcium from sarcoplasmic reticulum. When this action potential run in the T-tubule, it will result in release the calcium from sarcoplasmic reticulum. The functions of sarcoplasmic reticulum, it is rich in calcium ions, which store it mainly in cisterns during relaxation of the muscle and release it during contraction. اوكي، يعني الساركوبلازميك ده مستودع للكالسيوم. سكيليتال ماسل بتحوش فيه الكالسيوم ليه؟ اللي تستخدمه اثناء الكونتراكشن. بعد ما بتستخدمه مش بترميه، بترجع تلمه تاني وتحوشه تاني في الساركوبلازميك ريتيكولم والريلاكسيشن يبدأ. نشوف الساركوبلازميك ريتيكولم بيتكون من ايه؟ It is composed of two major parts. Large dilated chambers called terminal cisternae. Contact with the T-tubule. شوفها حالا في السلايد اللي جاي. And the longitudinal tubule that surround all surfaces of the actual contracting myofibrils زي ما شرحنا قبل كده. The site of contact between a dilated cisterns on both sides with T-tubule called triad. What's triad? The transverse tubule and the two terminal cisternae of sarcoplasmic reticulum called triad. As we see in the picture, terminal cisternae, blue color, and other terminal cistern on the left side, blue color, and on the right, one on the right and one on the left side, and the T-tubule in between. This called three parts called triad, and it is very important connection between them to release the calcium from sarcoplasmic reticulum. And as we said that the calcium is very important to start skeletal muscle contraction. Okay. Now, what's innervation of skeletal muscle? It is autonomic or somatic? No, it is somatic. Skeletal muscle are supplied by somatic motor nerve, which is the axon of anterior horn cell of spinal cord. One motor nerve innervate many muscle fibers. Okay, here is one anterior horn cell. This is its axon, and the axon supply one of muscle fiber, not one or two, maybe 3, 4, 10. Okay, يبقى one axon supply more muscle fibers. Okay, the contact between axon, okay, or somatic nerve fiber with the muscle fiber is called neuromuscular junction. and this will be inshallah start firstly in next lecture, contraction of skeletal muscle. Thank you, goodbye, and good luck.